Security Basics. About this course. Welcome to the Security Basics course. In this course, you will learn about threats to computer security and ways to keep computer systems and users safe. You will discover the differences between threats such as hacking, malware, and viruses, and you will examine vulnerabilities such as bugs and buffer overflows. You will explore key security measures to protect computer hardware, software, and networks. Learning objectives. After completing this course, you should be able to recognize common ways to make hardware secure. Compare and contrast authentication and authorization. Explain common threats to computer security. Identify ways information technology, IT, professionals protect users and systems. About this module. Module 1. Physical Security and Configuration Hardware. Introduction. In this module, you'll learn about security measures for physical computer systems. You will discover ways that information technology, IT, professionals keep users, computers, and data safe. Learning objectives. After completing this module, you should be able to describe ways to secure physical hardware. Explain how lock screens keep data safe. Describe how group policy might provide security in organizations. Compare and contrast mobile device management, MDM, and mobile application management, MAM. Case locks and lock cables. According to Gartner, a technology research and advisory firm, one laptop is stolen every 53 seconds. Source: 7 shocking statistics that prove just how important laptop security is, opens in a new tab, Security Boulevard, by Nathan Sharp, September 2018. As devices have gotten more pervasive, so have security threats. Keeping devices, information, and users secure is a major focus for IT professionals today. There are many ways IT professionals protect hardware. It's important that you use a few of the following methods to secure physical hardware. When you think about securing a computer system, your first thought might be to install a virus scanner or set up a firewall. You also need to secure the physical devices that you use on the system to protect them from threat actors. Threat actor. A threat actor is someone like a cybercriminal or an organization that is responsible for a threat or malicious impact on the security of an organization or an individual system user. Threat actors will use any opportunity to take an unsecured computer and steal the information on it. If a threat actor makes their way into an office building and gets out with a laptop or a mobile device, the impact might be devastating. Not only will the company lose the device, but also the theft of confidential information stored on that device can result in enormous financial loss to the company. A threat actor can also target computers left in places like an unlocked car, an unattended table in a restaurant, or an unsupervised bag on a chair at an airport. Lock cables and case locks are simple devices that help prevent threat actors from removing the computer or breaking into its case. Lock cables tether a desktop or a laptop to a structure like a desk or a post. Case locks prevent people from removing panels on a desktop. What about mobile devices? To keep smaller devices like your mobile phone physically secure, store them in locked drawers or zipped pockets. When you use them in a public place, be aware of your surroundings and who might be watching. Firmware tamper locks. Firmware is computer code that operates the hardware on a computing device. It's usually stored on a chip on the computer's main system board. Firmware tamper locks might indicate when the case has been tampered with. If it detects tampering, it helps to prevent the computer from starting up. Here are some situations where you might use tamper locks to secure firmware. Firmware tamper locks on credit card readers. Some credit card readers use firmware tamper locks. If a threat actor was able to open the case of a card reader, they might install a wireless device. The device then would send credit card information to a listener on each swipe. To prevent this, the card device manufacturers simply keep the device from working if it detects that the case has been removed. Firmware tamper locks on desktop computers. Desktop computers have firmware tamper locks that can detect if the case has been opened. In some situations, the tamper lock will just warn the user. In other situations, it will be set to prevent the system from starting up if malevolent firmware or software is installed on the machine. Lock screens. A lock screen is a simple software solution that helps keep hardware safe. A lock screen is like a lock on a door. If you don't have the key or passcode, you won't get in. Lock screens ask the user to provide a password, a biometric, face or fingerprint, scan, or a personal identification number, PIN, in order to access the device. While this protects the data and the user, it also can help deter people from stealing a device. For example, some devices allow only a certain number of attempts to access them. If you put in the wrong PIN more than a specific number of times, the device will lock you out. In some cases, it will reset the device, protecting the user's data. But in others, it will make the device unusable so thieves are deterred from even taking the device. Most companies have policies requiring employees to use lock screens, so computers automatically lock after a few minutes of being idle. It's often a lock that works with a simple keystroke. If an employee walks away from the computer and leaves it unlocked, then the computer isn't exposed for too long. How can IT professionals help? Encouraging good device protection habits. IT professionals help by ensuring employees use lock screens and educating about the importance of them. IT professionals can reinforce the behavior until it becomes a habit for employees. Over time, employees will feel uncomfortable about leaving their computers unlocked. Administrator access. One way operating system security has evolved is by enabling IT professionals to control access to operating system files and services. When personal computers originally were developed, any user was able to modify the operating system in any way they chose. This is called administrator access. This access resulted in a number of problems. For example, a virus might impersonate the user and take control of the entire operating system. Operating system designers changed the way they thought about permissions. They realized that most users do not need administrator access to make changes to the way the operating system works, to access core files that control how files and user data are managed, and to modify operating system services that interact with networks. While users do not always need access to core system settings, they do need to be in control of their own data on their device. They need to be able to change specific settings that affect their experience. They also need to be able to customize the operating system to a certain extent. With restricted administrator access, users cannot mistakenly modify important operating system files, and viruses have less of an opportunity to control the entire device. Many corporations now require employees to request special permission to have administrator access to their computer. Group policy. IT professionals can control many security features in a corporate environment. Group policy is a part of the operating system of many devices. Group policy software enables IT professionals to turn on and off specific settings such as administrator access on a device. They can change these settings physically on the device itself or remotely over a network. Group policy can be set for groups of users. For example, software developers need more access to parts of the operating system. For them, an IT professional might set a group policy while providing other employees with a different policy. Many organizations have multiple levels of policies. For example, a company might have a group policy that applies to every computer on its network for every employee. They also might have specific policies for employees in certain roles. Group policies have the ability to turn certain features on and off. For example, salespeople might need to be able to transfer files to thumb drives to give to clients. Human resources specialists might not need this ability. To keep personal data safe, a company might choose to restrict permission to copy files to a thumb drive to those salespeople whose roles require this ability. Determine a group policy. You're an IT professional responsible for determining group policy for your work group. Which of the following features would you put under group policy and which would you not? Mobile device management, MDM, and mobile application management, MAM. Imagine you're working as an IT professional for a large shipping company. The company recently allowed employees to use their personal devices for business purposes. This not only saves the company money but also gives employees the flexibility to use the devices they like. You're responsible for ensuring that company assets and reputation remain safe while enabling employees to use their devices for personal and business purposes. Mobile device management, MDM, and mobile application management, MAM, are tools that can support bring your own device, BYOD, employees and manage applications on employee devices that are owned and maintained by the employer. BYOD employees use their own personal devices for business purposes. MDM and MAM help organizations manage devices like mobile phones and tablets. Like group policy, MDM enables an organization to exercise control over which software is installed and allowed to run on a device and restrict or allow access to services and files. It can ensure a virus scanner is managing network access. MDM can detect when a device has connected to the corporate network to receive policy updates. Sometimes a device hasn't connected for a specified amount of time and doesn't have the latest virus scanner or operating system profile, making it vulnerable to potential security risks. In these cases, MDM policy can prevent the device from connecting to the network. Corporations also can restrict or allow specific applications on a device with MAM. MAM sets these policies. A company might not want their employees to install games on their corporate phones. Or they might want their employees to use only an operating system or a browser that the company has tested to be safe for the company's assets. What do you think? Think about where you use and store your computing devices. What security measures are you using to protect your devices? Type your response in the following text box. When you are finished, select Done. Writing an answer is a good way to process your thoughts. These answers are for your use only. You have the option to download your response and save it. It will not be saved in the text box when you move on in the course. Evaluate your thinking. Does your answer account for the following? Be aware of your surroundings while using your devices. It takes only a moment to lock them if you are leaving them in another room. In public spaces like restaurants and airports, take the same care to protect them as you would with your money or your identification documents. About this module. Module 2. Authentication and authorization. Introduction. In this module, you will learn how to protect systems from unwanted users. You will explore how systems identify users by their physical characteristics like fingerprints and faces. You'll also examine the ways two trusted networks share information with a single login. Learning objectives. After completing this module, you should be able to differentiate between authentication and authorization. Describe the ways authentication works in the cloud. Describe trusted networks. Explain biometrics security. Gaining access to a system, authentication. In the 1992 movie Sneakers, a team of thieves breaks into a bank. They encounter plenty of obstacles like security guards, alarm systems, and door locks. They successfully get past the security, break in, and steal a briefcase full of money. In the movie, the bank learns from the robbery what security holes and gaps exist in their system. Similarly, in the computer industry, security professionals have learned from threat actors and have implemented more effective security measures. Authentication, Auth-N, is a security measure that strengthens access points. Authentication allows only appropriate people or systems to enter a network and keeps others out. Lock screens provide an authentication service that allows only people with valid usernames and passwords to access to a device. Devices also can authenticate users with other methods such as fingerprints, facial recognition, voice prints, and even retinal scanners. Gaining access to resources, authorization. Say a child wants to get a snack and goes into the kitchen. You, as a parent, wants to allow the child in the kitchen and prevent them from touring on the stove. The knobs of the stove are above the oven door a few inches above the floor. How would you keep the child from turning on the stove? Many appliances have a small, built-in security device called a child lock. Depending on the appliance model, adults enable the child lock by pressing a button for a few seconds. To turn off the child lock, they press the same button for the same amount of time. Most children don't know about this special button. The child lock prevents the child from activating the appliance and helps to provide a safer environment for them in the kitchen. Authorization, auth, provides access to resources within a system. While authentication allows or prevents a user, or another system, from accessing a device or a system, authorization gives or denies them permission to use certain resources once they have been authenticated. How can IT professionals help? Providing access protection. IT professionals ensure that sensitive information is protected from people who have access to a network but might not have authorization. While an authenticated user can join the network, there might be many areas of the network that only certain individuals access. Employee data is a good example. Human resource personnel have access to personal information about employees while everyone else can be restricted to honor privacy. Authentication and authorization working together. On many devices, authenticated users are automatically authorized to access the resources on the device. Files and services get the credentials that the device used to authenticate the user. When you log into your mobile phone, the operating system automatically gives you permission to read and write files, access settings, and download applications. This isn't always the case in corporate environments. Sometimes users have authorization to do some tasks but not others. Today's mobile device management tools enable IT professionals to lock down certain settings and leave others open for the user. In both cases, authorization works with authentication to identify a user or another system and enable or disable access based on a policy. Which is authentication and which is authorization? Check what you've learned about authentication and authorization using these examples. Authentication and authorization in the cloud. Many popular movie streaming services have a feature for creating a profile for each person in your home. For example, you can set up child profiles with built-in restrictions on certain types of movies. Authentication, the profile, determines what type of access the child has. Authorization. Some of these services might have a setting that requires a password to stream certain features, say R-rated movies. In this case, you have a single account for the family that uses a single authentication, the family profile, but to watch specific movies the user needs to be authenticated with a password. These security measures come from a cloud service. Cloud services are able to use different types of data to determine whether a user is authenticated. Some digital streaming services attempt to prevent account sharing. They look at your location by using the IP address of the device that you are using to attempt to log in. They can also use zip codes. They are able to prevent access if you use an IP address that is outside the range of zip codes for that account. Pass-through authentication. Imagine you're a student doing research with professors and students at another university. You share documents and other resources back and forth. To access your resources, you log into your university's network and have access to your files. To see your colleagues' resources, you are given separate credentials to log into their network. Would it be easier and more convenient to be able to access the resources at the other university without having to log in twice with two sets of usernames and passwords? With pass-through authentication, single sign-on, you can. You may have seen this type of system in use if you've logged into a cloud service, say a music streaming service, using your social media profile. In this case, your social media service is trusted by the music streaming service, which means it will not put the service at risk. So if you log into your social media profile, that service tells the music company to trust you. Your identity is verified by your social media provider and then passed through to the music service. Networks can determine the source of a network request using information like IP addresses and domain names. Because of this, institutions like schools, businesses, and companies are able to set up a trust relationship between various networks. Entities in trust relationships share limited user information. This makes it possible for you to get your colleagues' resources at the other university when you log into your own university's network. As long as you're logged in and access the resources from your university's network, you'll be authorized on the other network and be allowed in. Multi-factor authentication. Have you ever tried to make a purchase where the clerk asked you for two pieces of identification, ID? One ID might be difficult to fake. Two is even harder. This is the basic principle for multi-factor authentication. Multi-factor authentication requires users to enter one or more pieces of identification, such as a username and password combined with an authentication code, to access a computer, system, or service. Some companies use physical cards or USB dongles as a second form of identity. When you log into a device or a website, you might need to use a username and password and provide a code sent to your email or mobile phone. An identity application is another form of multi-factor authentication. The identity application shows a unique string of numbers that changes every minute. You need to enter that number in a form for access. Some companies use physical cards or USB sticks as a second form of identity. Balancing identification and user experience. Whether a company uses two or possibly more than two forms of identity will depend on the type of system or data that needs to be protected. IT professionals have to weigh the risk of loss with the user experience and find a balance between the two. Requiring multiple forms of ID too often might create excessive friction. Requiring it too infrequently might put valuable resources at risk. Using a mobile phone for multi-factor authentication. A mobile phone works well as a secondary piece of identity. Mobile phones typically have significant cost associated with them, so people protect them. Are tied to a single mobile number. Have a number that is tied to a specific account and one person on the account. Are generally always with a person. Biometrics. Biometrics are biological measurements of the features that are unique to you. Biometric security uses unique aspects of the human body for identification. Many mobile devices use fingerprint scans, facial recognition, or voice matching to uniquely identify a person. Biometrics should be backed up with other forms of identity for special circumstances. When people were required to wear masks during the height of the COVID-19 pandemic, facial recognition software was largely ineffective. Gloves can make using a fingerprint for identity cumbersome. If biometrics doesn't work on the first couple of tries, most software will fall back to another form of identity. How can IT professionals help? Using biometrics. IT professionals need to think through all the situations that will require authentication and authorization and determine where biometrics fits. It's a powerful tool that will be growing in usage and opportunities as technology advances. About this module. Module 3. Security Threats. Introduction. In this module, you will explore ways threat actors attempt to break digital security. Not all breaches are based in software. You'll learn that hardware is just as vulnerable, and you will discover ways to protect both hardware and software from threat actors. Learning objectives. After completing this module, you should be able to identify various types of threats. Compare and contrast social engineering threats with malware. Identify the differences between an ethical hacker and a malevolent one. Explain ways IT professionals can keep their users and devices safe. Threats to physical devices. A study of 550 organizations across 17 countries and regions who had data breaches concluded the global average total cost of a data breach is $4.35 million. Source: Cost of a Data Breach 2022, a $1 million race to detect and respond, opens in a new tab, IBM Security. Organizations can experience costly incidents where information is stolen or taken from a system without knowledge or authorization. IT professionals have to manage many kinds of threats. An IT support professional might be responsible for the security of hundreds of users using a variety of technology along with server farms, the cloud, and remote work. Threats to physical devices. Although much of the news about digital security focuses on virus protection, strong passwords, and data breaches, IT professionals can't afford to ignore the physical security of hardware. IT professionals need to think beyond protecting only the data in a device but also think about how to protect the physical devices. Losing a single laptop or a phone can be expensive for individuals and for businesses. When a device is stolen, the data stored on the device is compromised. However, device security must not only focus on theft. Physical threats can include attacks like denial of service, DOS, attacks, which overload a network with so many requests that hardware is not able to keep up. Or hardware may fail due to malevolent attacks, power surges, and power outages. How can IT professionals help? Protecting the health of the organization. IT professionals should think of their digital environment as a living thing that they must keep healthy. They should consider the types of threats it is subject to as well as where and when it is most vulnerable. In both of these considerations, they should think about the hardware as a part of the defensive posture as much as the software and services. Threats using physical output. In the 2015 movie The Big Short, a character named Charlie Geller looks at the camera and cautions, "People hate to think about bad things happening, so they always underestimate their likelihood." Similar thinking can happen in office spaces, leading to data loss, leaked corporate strategies, or privacy breaches. Not only do IT professionals need to focus on digital information, but they also need to manage physical tools like printers, thumb drives, handwritten notes, and whiteboards, which can contain sensitive information. Consider the security around a central printer. Many printers have a document caddy, a tall appliance with slots that hold printouts, nearby. Printer caddies contain printouts that are ready for pickup. Caddies can fill up quickly. Each of the documents in the caddy represents a possible security or privacy risk. An employee's performance review, an email from an executive about an unreleased product, or a printout from a spreadsheet about yearly earnings all might be picked up by the wrong person. A simple mitigation to this problem is to set up the printer so it prints a cover sheet for each print job that has a name and time on it. Fishing. A common saying among people who fish is, "You can't catch any fish if you don't have any bait." A person who fishes might use a berry, a fly, or a worm as bait. On the internet, threat actors don't use berries, flies, or worms, but they do use bait. A modified spelling of phishing. Phishing describes attacks that come in fraudulent emails, text messages, phone calls, or websites designed to trick people into downloading malware and sharing their sensitive information. Threat actors often use phishing tactics to collect information like credit card numbers, passwords, and any other sensitive data that can be used to access bank accounts, networks, and even governments. Cybercriminals lure unsuspecting people into actions that expose themselves or their organizations to cybercrime. How can IT professionals help? Educating users about scams. One of the best defenses against phishing scams is user education. While IT professionals are able to use tools to help mitigate attacks, educating users on how to recognize a scam email, what questions to ask a suspect caller, or methods to use to verify the identity of someone they don't know is also important. Hacking. Imagine you come home one day and try to enter through the front door of your home. You reach for your key and realize it's missing, or you try the keypad and your code doesn't work. You might then try another door of the house to see if you left it open. If there are no doors open, you might try a window on the first floor. If you discover the windows are locked, you might then try more and more unconventional ways of getting into your house. While the term hacking has become associated with malevolent actors, A hacker is simply a creative technologist who figures out how to accomplish something difficult using non-standard means. Unfortunately, many hackers use these skills to steal data, cause mayhem with a virus, or influence behavior through keeping a system for ransom. For example, a hacker might inject malicious code into a system by filling out a form on a website with data that corrupts a database. In other words, they are going to try every window, standard door, and dog door until they get into a system. A key defense against malevolent hackers is to work with ethical hackers. These individuals have hacking skills and can help you think like a hacker. They don't use their skills to cause harm. Ethical hackers can help IT professionals find vulnerabilities in their infrastructure. Social engineering attacks. Social engineering attacks take advantage of an expectation to trust requests for help. Phishers exploit this expectation for personal gain, and your loss. Other types of social engineering attacks separate questions to gather information in a roundabout way. For example, a caller may say they're from your bank. In order to get your social identity number, like a social security number, they start by asking for the last 4 digits. Then they ask other questions like your name and address. They might switch things around and ask you to verify your social identity number by providing the first 3 digits. With enough questions, they eventually get the whole number. Social engineering attacks are a particularly insidious form of attack as they tend to erode your trust in technology. A stolen identity has the possibility of impacting a person for decades. If a person loses their identity from an insecure device, they might be very reluctant to trusting technology again. For example, suppose you get a call from a person who claims that they're calling on behalf of your company, which is IBM. They tell you IBM authorized the call. They start asking for personal information to try and access your insurance information. You're not sure if it's a scam or not. To protect from social engineering attacks, ask the caller to provide the name of the supervisor at their company who authorized the call. Ask the caller for their first and last name, and employee ID. If the call is legitimate, then the caller would be willing to provide this information. A scammer won't be willing to provide this information. How can IT professionals help? Using defenses against social engineering attacks. IT professionals help demystify social engineering attacks by educating users on what to look for. They also teach users how to take an offensive and defensive approach, particularly for ambiguous situations. Malware. Malware is a combination of the words malicious and software. The goal of malware is clear: to cause harm. Malware comes in many shapes and sizes. Some forms are merely annoying, such as a box that says, "Click here," and moves when your mouse approaches. Other malware is much more insidious. Keylogger malware keeps track of every key a user types on a keyboard. Threat actors can use the output logs this type of malware to learn passwords, file locations, and sensitive personal and corporate data. Some malware doesn't have an immediate impact. It runs in silence in the background, either collecting data or waiting for a signal. When it receives the signal, it can contribute to a launch of a coordinated attack on corporate servers or other systems. Many companies have launched offensive efforts against malware engineers and the servers that distribute them. How can IT professionals help? Defending against malware. IT professionals can defend against threat actors by ensuring that all devices have virus and malware scanners with the latest profiles. Like a goalie in a soccer game, an IT professional can block every attack and help their team secure a win. User education goes a long way as well. IT professionals can train users not to install malware or viruses by selecting a dangerous email or visiting a malicious website. Determine the type of threat. Check what you've learned about different types of threats using these examples. About this module. Module 4. Software Security. Introduction. In this module, you will learn about security methods that protect software. You'll explore encryption, certificates, firewalls, containers, and virtual machines. and you'll discover what software engineers and IT support professionals can do to protect software from malicious attacks. Learning objectives. After completing this module, you should be able to describe encryption, explain the purpose of a firewall, explain the ways IT professionals use virtual machines and containers as security tools, describe certificates and the role they play in a secure environment. Encryption. Many, if not most, digital security breaches happen at the software level. With lines of code in the trillions, software can have many attack vectors. Bugs are errors or flaws in code. Some bugs can make the software vulnerable to attacks. Computer engineers are responsible for fixing bugs. IT professionals look for ways to live with bugs until a resolution is available. As a child, you might have developed a secret code with friends. You would have replaced letters with numbers or replaced letters with symbols. You would send encrypted messages in code to each other. Encrypted messages are called ciphers. In order to write or read a cipher, you had to have something that helped you translate between the cipher and natural language. That thing was a key. Encryption is a method used to scramble important data and information so others are not able to understand the information without a decryption key. One of the most important developments in software and data security has been the implementation of cryptographic software. Using cryptographic software, data is encrypted and a special key is used to decrypt it. With the advent of large networks, encryption has likely prevented an inestimable number of breaches. There are two types of encryption in use today, symmetric and asymmetric. Asymmetric encryption. Asymmetric encryption, also known as public key cryptography, encrypts and decrypts data using two different keys to encrypt and decrypt data. Public key encryption, for example, uses two different keys to encrypt and decrypt data. One key is public and the other is kept private. The use of two different keys is what makes it asymmetric. Symmetric encryption. Symmetric encryption is a type of encryption where only one secret key is used to encrypt the non-encrypted data and decrypt the encrypted data. Private key encryption is symmetric in this way. Containers and virtual machines. When a cook cracks an egg, they usually use a bowl to make the egg easier to work with. If they cracked it on the counter, the egg would ooze all over the place, creating a big mess. Containers and virtual machines are two technologies that help improve security. In a security environment, they can function like a bowl for the egg. When something breaks, it keeps the result from making a mess. Containers are small bundles of software that include only parts of an operating system needed to run specific code. A virtual machine, VM, is software that mimics hardware. A virtual machine can run inside the operating system of a particular desktop, laptop, or server. Multiple VMs can even run on a single hardware device. In order to use a VM, engineers install full versions of operating systems and then use them as they would any other device. Containers, in contrast, don't require a full version of an operating system. They use just what is essential. Think about the difference between a large, 18-wheel transport vehicle and a standard family car you or your neighbors might drive around. You'd need an 18-wheel truck to get tons of groceries to a market, but you'd only need your family car to get a few bags of groceries to your home. VMs tend to use a lot of resources and compute power. For tasks such as running a single function for a service, containers might be a more efficient option. How can IT professionals help? Using containers and VMs to control environments. IT professionals are able to set up containers and VMs to run software in a very controlled way. They can identify applications that require an extra layer of trust to run in these environments where they can carefully monitor the applications. They can also sandbox the applications. Sandboxing isolates software but runs it in a way that mimics a real-world environment. Containers and VMs help create this environment. Certificates and tokens. When you present a driver's license or a passport, you're showing documentation that an authority has verified you. The documentation provides your credentials. A digital certificate acts as an electronic credential to verify a person or system digitally. In this respect, a certificate is like a driver's license. A certificate has a unique number for identification purposes. It is issued from a certificate authority, CA, that verifies the certificate as authentic. For authentication purposes, certificates make use of a public key and a related private key. The issuing CA links these keys along with other information about the certificate owner to the certificate to securely identify the user or system. Authorities can issue single-access tokens that function similarly to certificates. While certificates generally are used many times before their expiration dates, tokens are limited by the time they can be used. The temporary nature of tokens can reduce security risks by limiting how many users or services have access to a system at a given time. Certificates can cause problems if they expire or if the issuing authority revokes the certificate for some reason. Revocation can happen if the private key has been compromised. How can IT professionals help? Keeping certifications secure. IT professionals are responsible for ensuring certificates are kept current and for protecting private keys. Firewalls. A firewall is a virtual barrier between your network and other networks. Firewalls are programs, either software or firmware, which provide network security. They monitor incoming and outgoing network traffic and will block anything that contains viruses or threats to your system. Network traffic communicates over ports based on the network protocol being used. There are over 65,000 possible ports network traffic can use. When you browse the web, you use the Hypertext Transfer Protocol Secure, HTTPS, protocol in the web address. The HTTPS protocol communicates over port 443 on a standard network. Traffic that travels to your browser over port 443 contains the type of data that the browser can recognize. Computers use ports to manage traffic and applications. Follow your email through a port. When you send an email, the data travels over a particular port from network to network. The following process follows an email to illustrate how data travels over a network through ports. Select Start to begin. Step 1. You send an email to a friend from your home network. Step 2. Your firewall has port 25 open for outbound traffic and sends the email to servers on the internet. Step 3. The email is routed to your friend's email provider. Step 4. Your friend checks for new email in their email application. Step 5. The email provider sends the email using the SMTP protocol, which uses port 25. Step 6. Port 25 is open on your friend's computer and the firewall allows in the email data from the network. Step 7. Your friend's email application receives the email and your friend reads the email. Summary. You followed the email from your home network to your friend's email application. You just learned how an email travels over networks. Email is delivered to devices on port 25 and that helps networks manage email traffic compared with other types of data. Firewalls manage ports on a network and watch the traffic over ports. The more ports a computer has open, the more opportunity for issues. For example, suppose a firewall opened all ports on a computer. A virus then made its way onto that device that was designed to communicate over an obscure port. In this case, the virus would be able to do damage. If the port were closed, the impact of the virus would be limited. Firewalls keep devices and networks safe by taking a better safe than sorry approach. Many firewalls only open ports for well-known applications like email, web browsing, and other popular applications and services. If an application needs to use another port, the operating system must ask for permission from the user. How can IT professionals help? Managing firewalls. One role of IT professionals is to manage firewalls for the devices on their network. IT support professionals ought to work with their organization to ensure that firewalls are as secure as they need to be without being too restrictive. If a corporate application requires a port to be opened and the policy has it closed by default, This can result in unnecessary support calls. Good code. While many security measures are defensive, writing secure software is preemptive. Several decades ago, as personal computers were becoming popular, software engineers hadn't developed methods or patterns for how to write good code. Tools then were rudimentary, sometimes just consisting of a basic text editor. As a result, hackers found plenty of opportunities for exploits and malware attacks. One common issue that programmers have struggled with is a buffer overflow or buffer overrun. If the developer has not checked the length of the data being held by a variable, malware can send valid data in the first part of a string and then add malicious code to the end. This data flows to another memory space where the malware might access it. Today developers have better development tools to monitor and alert them to code that might be subject to this vulnerability. Today's software development involves rigorous patterns to follow, particularly for software that deals with sensitive data. Software development tools perform real-time checks for potentially insecure code. Testing tools also help developers find potential issues they might have missed. Determine security measures. Check out what you've learned about IT support activities using these examples. Explore more. Would you like to know more about software vulnerabilities and threats? Check out the Open Web Application Security Project Registered, OWASP, Top 10, opens in a new tab, for a list of current, critical software security risks to be aware. You've come so far and learned so much. You learned about the threats that loom over computer use and what you might do to neutralize their effect. You discovered security measures that IT professionals use to provide simple and effective ways to manage computer security. Now that you've completed this course, you should be able to recognize common ways to make hardware secure. Compare and contrast authentication and authorization. Explain common threats on computer security. Identify ways information technology, IT, professionals protect software, users, and systems. Key points to remember. 1. Keeping devices, information, and users secure is a major focus for IT professionals today. 2. Lock cables and case locks are simple devices that can prevent threat actors from removing the computer or breaking into its case. 3. IT professionals educate users on the importance of using lock screens. 4. Group policy software enables IT professionals to turn specific settings on and off on a device. 5. Mobile device management, MDM, and mobile application management, MAM, are tools that support bring your own device, BYOD, employees. 6. Authentication, Authn, allows only appropriate people or systems to enter and keeps others out. 7. Authorization, Authz, provides access to resources within a system. 8. Authorization works with authentication to identify a user or another system and enable or disable access based on a policy. 9. Cloud services use different types of data to determine whether a user is authenticated. 10. IT professionals balance the risk of loss with user experience. 11. Biometric security uses unique aspects of the human body for identification. 12. Like software and network security, hardware security is essential to keep systems and users safe. 13. Phishing attacks come in messages designed to trick people into revealing sensitive information or taking actions that have a negative impact on themselves or their organizations. 14. A hacker is a creative technologist who figures out how to accomplish something difficult using non-standard means. 15. A key defense against malevolent hackers is to work with ethical hackers. 16. IT professionals train users not to install malware or viruses by opening a dangerous email or visiting a malicious website. 17. Encryption, containers, virtual machines, certificates, trusts, and firewalls are software security measures that IT professionals manage. 18. Software bugs are flaws in code, but good code writing tools and practices help protect code from vulnerabilities like buffer overflows.